Hi, in this video, we're going to talk more about the link local address, how to verify the link local address, and also a little bit about duplicate address detection, which we'll talk more about later. But let's get started. Okay, so verifying the link local address. On router, we can do show interface gig 00 to look at the MAC address. And when I do show IPv6 interface brief, I see the link local address. Now, why am I showing the MAC address? Because by default, Cisco iOS will use the MAC address and EUI64 to dynamically, automatically create its link local address. Okay, so we can see the relationship here between the MAC address and the link local address. Okay. If I manually create a link local address, notice that we do not have any kind of relationship here between the MAC and the link local address. Okay. But show IPv6 interface brief or show IPv6 interface will show you all your addresses, global unicast address, and link local address. Okay. We'll see the link local address when I look at the IPv6 routing table. So here's an example of the router learning about some remote networks from another router. And it's always the next hop address. So here we have, just so we're clear here, here we have the remote networks. Okay. And it's learned about this route via OSPF. Okay. But what I want to show you here is the address of the next hop router. When this router gets packets for, let's use this network prefix that belong to this network prefix, it will forward them via this next hop router. It tells us the link local address of the next hop router. Do you see the importance of manually creating, excuse me, a link local address? Here I can kind of see this by, the way that I've created my link local addresses. This first one is router R1, and the second one is router R3. Okay. Okay, link local addresses and duplicate address detection. So I'm going to talk more about this when we get into ICMPv6, but you might be wondering, hey, when a device, a router or any device, creates its own link local address, how do we know that's unique on the link? So here we have the Windows PC. Let's say it created its own link local address, FE80, and then locally generated interface ID. Could be a random number, could be EUI64. Windows uses a randomly generated number. Well, what it will do is it will send out a neighbor solicitation message. Basically, it's like ARP for IPv6. It just says, hey, everybody out there. So this is sent to everybody on the link, okay? And not the router won't forward this, but everybody on this network will see this. It's saying, hey, who out there has this link local address? Send me your MAC address. Now, of course, this device is hoping nobody else has it because it wants to make sure, it's hoping that this address is unique. And after a certain period of time, it will wait a little bit, and if it doesn't get received what's known as a neighbor advertisement message, similar to an ARP reply, it says, oh, nobody else must be using this, so it's safe for me to use. We'll talk more about that later, but duplicate address detection, this process is recommended for all unicast addresses, whether they're statically created, DHCP, or some other way like stateless address auto configuration. So it doesn't matter how the unicast address is created on the device, duplicate address detection is recommended just to make sure that there are no duplicates. And although it is only recommended Just about all operating systems will do this. Okay, if there is a duplicate on Cisco iOS, we'll display, hey, there's a duplicate address. Okay, and we'll actually say, I've installed this address. Okay, but I've made a note, hey, this is a duplicate address, FE80:1. And although I've installed it, I'm not going to use it. Okay, so it's unusable. So yeah, that's my address right now. I can't use it because there's a duplicate, meaning somebody else replied saying, hey, with a neighbor advertisement, hey, I'm using that address. Or they didn't say, hey, I'm using that address. They come back with, oh, you're looking for my address? Here's my MAC address. And that's what you don't want to hear because there's a duplicate. Okay, let's talk a little bit about linked local addresses and default gateways. Unlike IPv4, IPv6 can only get its default gateway address automatically from a router advertisement message. We've mentioned this a little bit in an earlier video. We'll talk more about it later. But the router advertisement, the source address is the router's link local address. This is how the devices on this link will get its default gateway. They will not receive this address from a DHCP server, like it does with IPv4. DHCP v6 does not provide this information. But we can actually see that here's the source IPv6 address of the router advertisement, and that's what gets installed as the default gateway address for the WinPC. And there we see, remember that? The zone ID, meaning, oh, this is on the wired LAN. And yep, that's the zone ID for the wired LAN, excuse me. Okay, so how do we ping a link local address? We talked a little bit about this already, but there's a little bit of a dilemma with pinging a link local address. For example, from a Cisco router perspective, when we say ping FE80:2, well, who has that address? Okay, because remember, this address can exist on any link as long as it's unique on that link. It could belong to router B or a client on one of its Ethernet interfaces. All right, so in Cisco iOS, if we said ping and a FE80:1, let's say I wanted to ping the link local address of router R1, iOS will come back and say, sorry, but what exit interface do you want to send this out of? Do you want to send it out this interface, gig 01, or do you want to send it out this interface, gig 00? You have to tell me because this address could exist on either interface. Okay, so in this case, we say G01, but there's a problem. For some reason, Cisco doesn't want you to put an abbreviated or shortened exit interface. You have to write it out, gigabit Ethernet 0/1, okay? Without spaces. Here's a use full interface name without spaces. Okay, so it's going to send it out the gig 01 interface, and it gets a reply from router R1. Okay, in a Windows PC, remember, we don't have to, Windows PC will just send it out, whatever interface is most efficient. Remember, your routers will have multiple interfaces on different networks. Your clients typically belong to one network, okay? So it knows that this interface ID is just going to be on its one network. Okay, that's Windows' take on it. It says, look, I typically only, I only belong to one network, so I'm not going to ask which interface. Again, remember we did the net SH IPv6 show interfaces, gives me my zone IDs. Okay, I could ping a link local address and give the zone ID. Okay, so this is my local area connection, my wired connection. In this case here, I'm not on a wireless, I'm just on the wired. But I could specify the zone ID if I want. Linux is a little different. First of all, we use the ping6 command. If I say FE80:3, Linux complains, says that's an invalid argument. I need to know the zone ID, sometimes called the interface scope. So if I do ifconfig, I see, so here's my interface scope. Okay, this is the interface, or so it's a ETH0. Here's my link local address. Okay, and the scope is link local, and it's only good on the link. Okay, so now if I say ping FE80:3, I actually have to put percent ETH0. I mean, I want to send it out that interface. Okay, so in Linux, I actually do have to specify it, and that's where I get the zone ID or interface scope. Okay, there's actually two ways I can do it in Linux. I can do percent ETH0, or I can use the, say, ping6, use the -i interface parameter, specify ETH0, and then just give the link local address. Both of these will give me the same thing. Mac is exactly the same, only different. Again, I use ping6, and again, it complains if I don't use the zone ID. But it's slightly different. It doesn't use ETH, it uses EN. So when I do ifconfig, I can see I have this is my Ethernet interface. It uses EN for Ethernet. And here's my link local address, my global unicast address, okay? But what I want to do is I want to ping it, the link local address. So say the router, I have to say ping6 FE80:1. That's my router's link local address. And I have to say percent EN4. Okay. Again, I can use the interface parameter, the -i interface parameter, but both of these are associated. Maybe I should put all this, there we go, are associated with EN4. So that's how you find out what your zone ID or interface scope is. Use ifconfig on Linux or Mac. Okay, and that's it for verifying the link local address.